We have about 123 students join the meeting. I hope my voice is clear. If you see any problem, just let me know. Thanks so much. We'll just wait for a couple of minutes and then we can start our lecture for today. Let's see, about 128 students. Maybe in 1 minute we'll. Yeah, people start asking questions. So let's just start talking to each other first before we get into details of the course. Good afternoon, everyone. Yeah. Thanks. The break was good. I hope you guys had a good break too. I know it's a very unusual time for everyone, and I wish we had the opportunity to meet face to face in the lecture room, but yeah, maybe in another course. Um, I know how is everybody. I guess we should start now. So I hope everyone is like keeping up, and I really understand the stress like all the students have. I myself have a son who is in the University of Guelph, so I know exactly how he feels and also how you guys feel. And I'm gonna do my best to make these learning experiences is interesting and useful as much as I can. I try to develop the online material differently a little bit from what I used to teach the fluid mechanics in the past, just to get into more benefit of the online learning process. Let me just start by introducing myself. My name is Wael Ahmed. I am a full professor at University of Guelph. I joined 2014. I've been teaching several courses here as well as in the past. Let me share with you the screen and maybe we start giving you a quick idea about my background and how the fluid mechanics is going to be taught in this semester. I hope you can see all the. Can you see this? Not sure if. Yeah. So I don't see the chat area here. Okay, so I don't see the chat at the same time with.
We can see it.
I think, okay. Yeah, I have to open it. Okay, perfect. Okay, so as I mentioned, I am Wael Ahmed. I'm a professor at University of Guelph. I'm a full professor at University of Guelph, and so I started by finishing my PhD at McMaster. I joined Atomic Energy of Canada Limited at that time in Chalk River. I did work with lots of power generation facility. I did work with OPG and Bruce Power and Gently 2 in Quebec. Been working a lot in something called multi-phase flow. I spent about 5 years in industry at that time. And then 2008, I joined the oil and gas sector in Saudi Arabia. I did work with lots of oil and gas companies, developing technology related to multi-phase flow as well. My main area is energy and fluid thermo kind of things. And then I joined Guelph in 2014, as I mentioned, and I started focusing more into food and energy systems. And now I become a full professor after 6 years. Been focusing so much of my effort here into something called multi-phase flow. And when we're talking about multi-phase flow, this is something very related to fluid mechanics. So multi-phase flow is a little bit much more complex system in, under the fluid mechanics subject. So you can imagine, like, if you want to design a coffee machine, so starting with an espresso machine, how this machine is working and how you evaporate the steam inside and with a certain temperature and pressure, and make sure that you have the best brewing experience for this. So multi-phase flow is one of the key elements behind designing this coffee machine. So going from coffee machine to power generation. So all the power generation sector, and here I'm talking about like large power generation sector. I'm talking about like, fossil plant, like nuclear plant. I'm not mentioning here the solar part or the wind part. So I'm talking here about like the mechanical large equipment for generating power using phase change, steam and other things. So power generation is one of the key thing that we work when multi-phase flow, as well as in aerospace. So aerospace industry has a lots of problem related to multi-phase flow. So we're talking here about starting from the cooling and lubrication system in these engines to like the propulsion mixture that is coming out of these rocket nozzles. So all these has to do with some understanding of the multi-phase flow sector. So as I mentioned in the past, I'm focusing more in my journey since I finished my PhD on working with industry to develop solutions for many industrial systems, and all these systems are somehow related to the multi-phase flow, as I mentioned, and it is basically under the fluid mechanics subject. I taught many courses in fluid mechanics in the past in multi-phase flow, and I believe that all the success story that I have in my life for both practical and academic world is it's based on some good fundamental understanding of fluid mechanics. So that's why I really believe that fluid mechanics understanding is very important subject to all engineers. Before I start, I want to maybe I created just only one poll here for your area of study in our School of Engineering. So I will just put this, so you have few seconds here to just show me what do you have for your work study area, to get an understanding of the demography inside the class. So at least I can, yeah. So you have a large number of mechanical students here. We have biomedical, we have environmental, and we have few in the system and computing. Cool. Perfect. Don't see anybody from water resources or biological. Okay, so maybe I'll just end the poll here. Again. Okay, stop sharing. Perfect. So this is giving me some idea about, like, some of the interests some of you have in this class, but I know that this is like a core course for everybody, and as I mentioned in just a few seconds, that there's so many applications actually that involve fluid mechanics analysis. And one of the things that we do in our lab here is, like, you can browse the website of our group here in Multi-Phase Flow. So we have very successful stories to share with you on the websites, and you will see a lot of students in my group from different disciplines. So I did work a lot with biological and biomedical students. I have a lot of mechanical students as well in my lab, system and computing as well. So lots of varieties and lots of research opportunity for you also, if you plan to maybe are interested to join some of our research projects in the third year, as well. So today's lecture, we're going to start with talking about fluid mechanics. So what is fluid mechanics and the importance of fluid mechanics? And then I will go into some details about the course objective and the course topics and organization as well. So let me start with what is fluid. I'm not going to get into details here. I'm just trying to give you an idea about, like, what is this course is all about and why is it important and how we're going to move forward with understanding some of these concepts. So we all know from the physics in the high school that matter exists in various states, gas, liquid, and solids. And this is a very general description of the matters, because some of these liquid can be solid or can be gas, depend on the temperature as well. But let's start with a very general idea about, the matter, the state of the matter. So gas, liquid, and solids. So fluids is basically the gas and liquids, and we're gonna understand a little bit more why we are defining gas and liquid under one category of fluid mechanics in the first chapter. But let me tell you for now that we are not focusing so much in this course on the solids. There are some other courses actually dealing with solid mechanics. I believe some of you are already taking this course now, kinematics and dynamics, and other people they take, mechanics course one. So all the forces on the solids have been covered very extensively in these courses. So what we are doing in this fluid mechanics course is focusing more into the gas and liquid parts. So mechanics, as you know, that it's a Greek word that is talking about the physics, deals with motions, right? So in this case, we are really looking into different way when we are looking at mechanics. We're looking at forces only, and maybe sometime we refer this without motion, we call it statics. And also sometime we look only on the motions and just describe the motion, the velocity and acceleration of bodies. And we can describe this in the science of kinematics. And if we consider the forces and the motion, we are concerned more of the dynamics part. So forces acting and creating motions of these particles. So as I mentioned, we're not going to deal so much with the solids part here, and we're going to focus on the fluid mechanics. And the course is basically a branch of the physics concerned with the mechanics of fluids and the force acting on them. So you expect in this course to understand a little bit how force is affecting motion of fluids, right? And we're gonna, I will try my best to relate all the material to some fundamental understanding of engineering applications. So I encourage everyone to keep asking question, why we're learning this piece, why are we learning this piece? Because it's very important to have some understanding why we are concerned with this very specific knowledge of fluid mechanics. Okay, I just collected some example for you here just to start the course. So aerodynamics, it's another branch of fluid mechanics. It's talking about the air and the gases flowing around bodies, starting from the design of the shape of the cars to the design of the airplanes in the military sectors. Also looking into the aerodynamics and the effect of aerodynamics on the blades of the wind turbine to generate power. So we do a lot of analysis using fluid mechanics here, and some of the stuff that you see in these pictures, these very colorful lines here, is representing some solutions when we are using computers to compute some fluid mechanics property. We call it computational fluid mechanics stuff. In some other area where we are dealing with liquids, we call it hydrodynamics analysis. And in this case, if we are looking into submarine motions under, in the subsea, or the propeller shape driving ships or big ships, or pumps in many applications, cooling, heating, power generations, city wastewater. Many of these applications involve fluids in their systems, and some understanding of fluid mechanics concept is very important to make some analysis for these systems. Again, other application related to design of equipment, and those equipment I mentioned before, it could be as very simple household equipment to a huge, big equipment that is used for power generation or turbo engine or airplane and so on. Air conditioning units, all these has some aspect of fluid mechanics in them. And when I say some aspect here is in order to design an efficient system, you have to have some understanding of how the system handling the fluid in them. Either cooling your house by connecting an air conditioning unit or a heating unit. You are heating this fluid, you are moving this fluid in the ducts, and you are creating some kind of thermal comfort inside your house. The fluid motion inside, in the house is one aspect also that we deal with when we understand fluid mechanics, because you want to make sure that air is distributed in a certain way, and the motion of the air is not really bothering people living inside the house. Temperature distribution is affected also by fluid motion and so on. When we are looking at airplane, we are interested to see how much the jet or the propulsion engine is creating a thrust for moving the airplane and so on. Or when we are looking here at the gas turbine on the left picture, we're talking about power generations. We boil water, we get this water to convert to steam, and this steam is pushing some turbine blade in order to rotate to convert these hydraulic motions, or hydraulic energy to mechanical energy, and so on. So not only equipment and mechanical system, but also, it's a very important to understand fluid mechanics aspect when you are designing, computational model for forecasting the weather, right? Or if you are designing cities and designing buildings, you have to really make sure that you understand, in terms of season-wise, the wind distribution around these buildings, as a part of your design as well. Not only in equipment, but also in our human body. So lots of biomedical students are interested in the flow of blood inside our vessels, or designing, let's say, for example, a spray for some of these medical equipment for spraying inside the nose. So those sprays and those particle size, and how these fluid will be vaporized and stuff like that, it's very important to understand it from conceptual fluid mechanics in order to design this system. I've seen people talk so much about the fluid mechanics analysis when they start dealing with COVID, and what is these 2 meter limitations coming from. These 2 meter limitations basically coming from simulations of fluid mechanics. So see what is the distance between the 2 people, and what will be the the possible kind of, spread of the particles if people are talking or people are shouting and so on. So all these have to do something with fluid mechanics understanding. So when I mention that, I'm not saying that everyone when he finishes undergrad, he will work with one fluid mechanics job. But what I'm saying here is majority of the application is actually require some understanding of fluid principle. Let's say, some of the application will require some deeper understanding more than the others. But I can say that fluid mechanics is in many applications, and you will be surprised to see yourself part of an industrial facility that has nothing to deal with fluid, but some of the equipment is used inside that is it requires some understanding of fluid mechanics principles. So the main objective of this course is, and that's my main objective of the course. So my style of teaching is always concerned with student understanding and how this understanding is very useful for carrying out an engineering job after you graduate. So I mentioned to you that part of what I'm doing is teaching courses related to energy, thermodynamics, and heat transfer and fluid mechanics. I have lots of undergrad research assistants in my lab, talking about the third year and above, working with my grad students in many applications. And most of the time I'm working on applied type of research. So the course of fluid mechanics is the first step into so many applications, as I mentioned. And the idea here is, our objective is to try to understand some kind of, conservation principles. So we're going to learn in this course how we deal with fluids, what is fluid, what is property of the fluid, and how we deal with conservation laws. How can we develop simple solutions for basic problems? And hopefully, if we understand these simple problems, later on we can maybe expand, our knowledge. If after you graduate, you want to continue working on this, or learning through your experience of practical experience as well. So as I mentioned, the course topic will be divided the same way, and the way that I'm going to teach the course is, like, as I mentioned, to try to focus on this element of understanding. So that's why we are focusing more on fluid property in the beginning. We have to have some feeling and sense of the fluid property, because selecting the fluid is very important in these systems. And then we'll cover some static analysis for fluid flow, flow in the pipes, external flow pumps. So, and as I mentioned, fluid mechanics is a huge topic. We cannot really cover everything in details, but I will do my best to select the very specific part of each chapter that's the most important for students to learn. And I encourage you to really feel the same way about the course. Part of the organization of the course is a course textbook. I selected this Frank White's book because it's a good book, as well as that there are people who are taking this course in the fall and the winter. I don't want to make dramatic change into many of the students actually taking the course in the School of Engineering. So, and I guess Frank and White is a very good course. You don't need to buy the book, because I'm not going to attach anything to, like, assignment or anything to the book that is going to be graded. But all the material or the problem or every single activity that we're going to do it from the book. So if you you can buy the book, or you can buy the online copy of the book as well. Okay, lecture topic and figures are all based on this book. Problem sets and tutorial questions will be taken from the same textbook. Having said that, I'm going to create my own notes, and those notes will be posted on the course link. Lecture on Tuesday and Thursday. will be live lecture as we are doing it right now. I hope it's good for you. I know some people have different ideas. I actually start thinking about, like, maybe recording some of these lectures. I feel bad now I'm not seeing anybody in the front of my screen because I feel like I'm talking to myself. But for some reason, I feel it's much better to have a live lecture because I feel much more, connected to you. And I will have my chat is open here so you can interact on the spot. I will do my best to make it, smooth and clean as possible. But let me know. I need to hear your suggestions, and if you have any other alternative, you can discuss it with me. Lecture will be in combination of PowerPoint and handwritten notes. So my plan is to also solve a few problems with you as we go. And the link to the recorded video. I know lots of people in the past, they have issue with, they want to record the lecture for some reason, as well as some people in the different time zones and stuff like that. So anyway, I don't mind sharing all the materials with everybody. So that's, as I mentioned before, that this is kind of a learning process. We'd like to help each other to get the most benefit of this course. So, but I hope people don't only rely on the recorded lecture. Like, try to maybe participate in the lecture, try to communicate, try to have more interactions. But at the same time, for any reason, the lecture will be recorded and posted. So anyway, just for an additional benefit of the course. Yeah, people saying here live lecture is nice, so I think so as well. I'm expecting you also to take some notes, right? So I'm teaching in the past. I know not so many people take notes, but it's nice to put some notes. If I'm verbally saying something and you want to write it down, that's fine. But whatever I'm gonna write down on this lecture, I will post it on the course link. Yes, I will post the slides on the course link. So after this lecture, you will see the slide is posted, the PDF of the slides, and once the recording is ready by Zoom, I will share the link to see the video. Okay. Okay, so the other part of this course is labs. Okay, so labs, I couldn't make it, physical lab. I had a lots of fights, but again, we had lockdown anyway. So even though if I plan it, it will have to be shut down because of the COVID. So the lab will be virtual, right? Which is losing big part of the intended learning experience, and I apologize for that, but what we did is actually we created videos for all the labs, how the lab is done, and so on, and we have taken data for you to use in order to create your lab reports. I know this is not the best for everyone and getting the lab experience and hands-on experience, but this is what we can do for now. But at the same time, I don't feel that doesn't make any sense to bring people and show them the video on the lab sessions. So there's no point of really just go and watch the video. If you have questions and stuff, yes, you can have questions during the lab tutorial sessions to the TA and explain a little bit more about like how you calculate some data, how you do like prepare the lab report. But out of convenience, and this is something I decided myself, we have tutorial this week. And if you wait for a few minutes, you will understand how I'm designed the course this way. So the lab will be like 5 labs, and those 5 labs are recorded videos. And there's going to be some due dates for this lab. So if I let me look at here, okay? So you see this slide. Lab 1, you see here the submission due date is 29th of January. The way I did it actually is because it is recorded lab. That's why I think it's better for you to do it anytime during this week of the lab, anytime at night, whatever. Like you just look at the video. If you have question, you have a whole week to ask the question in the tutorial sessions and so on, or email the TA, and then you submit the lab report by the January 29th, let's say the first lab, and this will be the midnight, right? This way it is very flexible. It is very, like, I don't have to really use all the energy of the TA just handling deadlines and all this, right? So let's spare our efforts on something useful. Okay. Labs are recorded, are posted on the course link. Now you can see them. The manual and the way that the lab report should be created, the rubrics for how the lab will be created, and everything will be put in the manual, right? So I consider this to be much more efficient way of doing it. So you will have the time to look into the lab video, review anything with TAA during the week, and then you submit the lab reports. Everyone in the whole class can submit the lab report at the same time. Okay. It doesn't mean that we are not going to use the tutorial and lab sessions. No, we're going to use it, but for something much more meaningful and useful. Okay. I'm not going to ask you to double your effort in this, but again, you will see here, tutorial and lab session will be, during this week of lab report submission, you will see there is something called tutorial lab help sessions. So TA will come prepared for solving some problems during this time. And at the same time, if you have some question about the lab, you can ask those questions. Okay. Some other week, we'll have no discussions about the lab, which is, there's no lab, due at this week. And we're gonna call these sessions of tutorial will be a problem analysis tutorial sessions. I created this. I hope this kind of activity will be useful. We'll try to work together on making it useful. So please, give me your feedback later on. Lab is 20, yeah, we just wait, and 20%, yes. Some people are asking questions. I will explain this in a few minutes. But so lab and tutorial. So lab will be virtual. Tutorial, every week there is a tutorial session, starting this week. And some of these tutorial sessions will be solving problem by the TA, and answering question about the lab. And some of the tutorial session is called problem analysis tutorial sessions. And what does it mean? So let's say if we have, for example, I have 50 students in each tutorial. So the TA will break rooms inside Zoom. We'll create like 10 rooms inside the Zoom at the same time. This breakout room will be separate. So every 5 students will be randomly selected to work together on some problems. Okay. So let's say problem 1. Okay. Yeah. Tutorial session is starting this week. Yeah. Okay. I'm answering some of the chat questions here. So during this tutorial problem analysis sessions, it is meant for more communication with the students and more one-on-one discussions. Okay. Some of these tutorial session, TA will solve the problem to everyone in the section. But in the problem analysis tutorial session, it will be dividing students into groups, and the group will work on problems. And as incentive for that, everyone is attending these problem analysis tutorial sessions will have 3% of the course grade, which is good, right? The idea here is to communicate more with the TA, to exercise, how to solve a problem during this week. And again, those problem analysis tutorial sessions, not every week. It's only 5 times during the whole semesters. Okay. But it is a way to maybe improve like the learning process, just to make sure that and I will tell you honestly about why I created this, because I know when you are talking about fundamental course, principal course, most of the time it is there's a lots of misunderstanding of a simple principles. And the only way that we capture this misunderstanding is by talking to the students and looking at the students, how he solved the problem and so on. So the idea here is, you will have 2 TA during these problem analysis sessions, including myself as well, some of these tutorial sessions, and we'll jump into this breakout room in the Zoom, okay? And we'll talk to every 5 students together. So we'll have a little bit much more, closer discussions. This will hopefully will help students to learn more about the subject. Okay, it doesn't mean that we are trying to create like difficulty or obstacles for you here, right? This should be a fun exercise. Again, it's done 5 times for the 12 weeks. It's only 5 of the 5 of these sessions will be problem analysis sessions. The other one will be the general tutorial lab sessions. And at the end, you get 3% if you attended these sessions, right? Doesn't mean that you have to solve the problem perfectly or not. It's just a matter of participations here. And those 5 will be 3% each. So this is 15%. So I consider this to be an interesting exercise. And that's why this week there is a tutorial. And we call it trial tutorial, okay? So I cannot read every chat links here, but I will answer some of them after I finish. So anyway, the tutorial this week will be going through a very simple, exercise. How we do this? Just try, just to make sure that we have all the technical issue is solved, right? So you're gonna, this breakout room and how it works and stuff like that. Okay, and maybe, one more thing is important for every student in every course is units and dimensions. So TA will discuss with you units and dimension this, this week, as well as going through the exercise of fixing any technical issue for Zoom breakout rooms. So you will see the course link, the course outline in the course link, and you will see here the list of all tutorial and labs and lab sessions and so on. Okay, for example, this January 11 to 15 tutorial trials. So it's more of like, coming in, how to break the room and stuff like that, how have some discussion about simple example of units and dimensions and so on. This is for the preparation for next week. So next week, we will have enough material that we can start solving problem on. And January 18 week, it will have a problem analysis 1. So everyone is attending his own section during the time of the tutorial sessions. Will be divided into random groups, work together on problems. And if you attended 75% of these sessions, you will get 3% off the mark. Okay. Okay. People are asking how the grades of the problem analysis. The grades here is about participation. I don't have other means of evaluating every single student in this while doing all this online. Okay. So if you show some participate, like, you're going to be part of a group of 5 students trying to solve the problem, asking questions, and so on. That's it. You get 3%. Okay. So you will see that. So the first week, this week is trials. Second week, next week will be problem analysis 1. Okay. And these are the 3%, right? The week after, the 25, is going to be a tutorial, which is solving some problem, answering, question about the labs and so on, right? Because at the end of this week, 25th to 29th, you are asked to submit the lab report. So you can discuss lab report with a TA. Okay, and so on. So you'll see here, problem analysis 1, tutorial, and then problem analysis 2, and then tutorial, and so on. Okay, so I hope this will be the objective of this exercise is achieved through this discussion. And I can tell you that I have seen, like in the past, when I did this kind of exercise actually, and I look at the students, some of them, they might misunderstand some of the concepts. The only way to figure out this is looking at the students, how they solve the problem and so on, and have some discussions, right? And you cannot believe how much this is important, because once you know and once you are corrected, and this is not an exam, right? So it's more of an exercise. It's a friendly exam. It's like informal stuff like that. So you will be surprised to see, like, oh, the TA is correcting this principle for me, or this, oh, I'm doing this mistake in when I solving this problem. Oh, I do this, silly math mistake. Oh, right. So all this is about correcting you during this session. So just to make the tutorial session is much more useful, instead of getting the TA to solve the problem and everybody's sleeping, or even not attending or anything like that. Okay, so that's my goal. Okay. Every week, starting next week, you will see a problem set posted on the course link. Like, let's say, for example, 10 problem, right? And it's going to be like 8 sets of problem will be posted. So every other week or every week, depend on the covering of the material. These problem set will not be marked, you are not asked to do an homework and submit it, because the week after the solution will be posted. And the problem set here will be our data bank for this problem analysis session. So we're going to solve some problem together in these problem analysis sessions during the tutorial sessions. Okay. I reduced the number of exams to 1 exam, midterm exam, right? Because I created this 15% for problem analysis. So now we have only 1 midterm exam and final. Okay. So the midterm exam is on March 2nd, and it's going to be during the time of the class. I know lots of people will have question about how's the exam and the hassle of the online stuff. So I know you're concerned about that. So as I mentioned, lab will be 20%. You have 5 labs, so each one will be 4%, and it is about the lab report that you submit. And it's going to be 5 problem analysis exercises. Okay, please make sure that you make use of these problem analysis exercises. Is going to be 15%, and then midterm exam will be 20%, and then final exam is 45%. Okay. In order to pass the course, you just need to get 50. That's it. Passing total 50. Yeah, I know a lot of people using different schemes and stuff. I don't care about that. Just okay. The idea here is to really get what I'm talking about here. Understanding principles of fluid mechanics to be a good engineer, to know how to solve problem involve fluids inside these systems. Okay. I can't catch up all the questions here, right? And respondents. Yeah, I know there's no respondents. I don't, And again, it's not about, okay, you have to really understand the concept here. Okay. We are spending our life through this course, right? Hours and hours of our effort, right? To learn something important about being a good engineer. Okay. I know it's not ideal in these words for people to be, they have, they go through an exam without cheating and stuff like that. But again, this is something that will be basically it's up to you, right? If you want to get the best benefit of this course, if you want to learn fluid mechanics, if you want to be honest with yourself, if you want to follow all the guideline for academic misconduct and all this kind of thing, this is some kind of it's very hard to enforce it. The only way that I'm gonna tell you that the exam will be in a way that will not allow you to really have time to cheat, right? You really need to understand the concept in order to do this, and that's why I created an exam to be an open book exam. because this is a typical for any engineer working in the field. Information is everywhere. There's tons of information everywhere, online, books, everywhere. So the good engineer is not about like, try to do something like, different than just finding the solution, okay? Finding the appropriate solution, finding appropriate equation, and linking these problem equation to the problem really in the industry, right? So you see a problem and you don't know what equation to use in order to solve, right? That's the idea, right? Equation is there, tons of information in there. Which piece of information useful in order to take and apply to this problem I have in reality, okay? So this is what you need to really exercise on, okay? I hope this is clear, and I again, like, I want to stress so much on academic misconduct, right? So, and this is very important to being as an engineer. So, engineer has to be ethical about the way that he's performing his job, right? So, so we will see this in the course outline and explained, and also the university guideline is talking about this very extensively, okay? But I totally understand your the time you are passing in and the stress that everyone has, and there is no point of really adding much more pressure for you. Having said that, I'm not just watering down the course. This course will be delivered in the best way that in my ability to make sure that you understand fundamental fluid mechanics, okay? And I ask you to put in, a good effort in order to learn the material. We are asking you to complete very reasonable task, right? In a very reasonable way. So please make sure that you follow, like, the guidelines for this course, okay? Communication during the course, and I know communication is very important, because many of you will have question about labs. Many of you will have question about, like, I've seen a lot of people here chatting in the, right? So just to make sure that, if you have anything to say in the chat, would be much better, because kind of a distracting, like, if it's something important, please post it. If it's not related to the course, or, don't post it, okay? So this is part of your time. So make sure that if you have something that is useful, or a question that's valid question, post it, okay? So questions, I know you're going to have a lots of questions about the course and course material and other things, right? So TA will be answering all problems related to the grade of the report, of the lab, some of the sessions in the labs as well, okay? And I also created some discussion forums in the course link. And this discussion forum is much easier to post your questions, because I can answer, same questions to everyone at the same time. So this will save our time as well. And only emails communication will be for very special accommodations. Now, my expectation, I think I explained a lot about my expectation for this course. I want to hear from you about your expectations as well. And if anything that is what I've said, like, it's not clear, or you need to have much more explanation. So I'm looking at the chat now, so I don't know. So people still asking, first lesson will be tutorial this week. Yes, it's going to be first. And I mentioned this tutorial session will be will be the trial, just to get into use of the Zoom and the breakout rooms and stuff like that, and also have a quick understanding of units and dimensions. I know units and dimensions, like, it's covered in many courses, right? But just like, reiterate on this from a fluid mechanics perspective. Do we get 3% for every problem analysis we go to and engage in? Yes. When is the tutorial? The tutorial is based on your section. So you will have, for example, today there's going to be some section 2, I guess. Section 2 at 3:30. And I guess, Arash, your TA already post a link on the course link for you to join. And it's going to be Zoom meeting as well. So Tuesday, today section 2. Tomorrow there is one section at 1:30, section 1, right? It's going to be a short tutorial, but it's mainly just make sure that we don't have any problem, any technical problem when we are running our problem analysis session next week. Tutorial is your lab, I think. I don't know. Okay, so I don't know, you're talking to me or you're talking to somebody else, but anyway. Lab result will be posted when I just submit them. I think it's like you have to give us some time to the TA to look at the lab report and solving them. But the Dropbox generated in the course link is when you submit your lab report. Once the grade is posted on the Dropbox, it will be shown on your grade for the course, right? So I will make sure that TA will be grading the lab report in a timely manner. So I have 164 students in the class. Everything is clear. No questions? No questions? Okay. Perfect. So I will end the session for today. You will see these links for the Zoom of the lecture every time, so Tuesday and Thursday, and also some links for your sections, either sent to you by email from the TA or posted on the course link. I will start posting the lectures and recording and everything. So yeah, good luck in the semester, and I hope you have a good experience in this course. Okay. Thanks so much, guys. Welcome, guys. Thank you, guys. See you next time. Take care.